Hello Bachcha Bhati, welcome to your channel TKG Physics classes. And all of you know we already completed 8 lectures from Laws of Motion chapter. And this is our lecture number 9. And in this lecture we will discuss frictional force. In this lecture we will discuss frictional force, type of frictional force and laws of friction. And then we will solve some basic conceptual numericals related to frictional force. So there are a lot of confusion when we apply static friction, when we apply kinetic friction, when we apply mu k, mu s. So watch this video till the end. I think all these types of concept will be clear to all of you. So open your copy and write down the notes. At first you have to know the meaning of frictional force. Friction is a type of contact force. Friction arises when two bodies are at contact. So this is the definition of frictional force. You see, friction, that is whenever a body moves or tends to move. So the basic concept, write it. At first, when a body moves or tends to move, that means there is a relative motion, or you can say tendency of relative motion. Tendency of relative motion. So this is the concept. Whenever a body moves and tendency of movement over the surface of another body, a force comes into play which acts parallel to the surface of contact, which act tangential to the surface of contact. So write it as third condition, that is which acts tangential, to the surface of contact and which opposes the relative motion. Always you say it opposes relative motion, not motion. So its direction of frictional force, that is opposes the relative motion. Okay, suppose this is surface, and in this surface a body of mass m is placed. So body initially at rest, no external force applied on this body. So in that condition there is frictional force? Answer is no. There is no external force applied, so there is no frictional force. Now suppose an external force F applied along the positive x direction, but the body, I observe that the body is under rest. There is a body and I am applying a small amount of force. So all of you know, initially a body, when we apply small amount of force, the body doesn't move. Body is at rest condition. So what about this external force? You apply this external force, but the body doesn't move. Body is under rest. That means this external force is balanced with another force, which is exactly opposite to the direction of F. This force is named as static friction. You can say this force is named as frictional force. So here, this is the surface of contact and frictional force is directed tangential. You see, this is the surface of contact and frictional force is directed tangential to the surface of contact. It is generally represented by the symbol that is small f. Okay, so at rest condition, when there is no external force, there is no frictional force. Now when we apply an external force, initially small amount, then you observe that the body is under rest. So that means this force is balanced with another force which is named as frictional force, and it is directed the tangential to the surface of contact, and it opposes the relative motion. The motion of that body will be in that direction, but the frictional force is directed in that direction. So it opposes relative motion of the body. Okay, now come to the point, that is the type of frictional force. There are mainly 3 types of frictional force. You can say also 2 types. This limiting friction is in the part of static friction. So There are three types of frictional force, that is static friction, limiting friction and kinetic friction. You see the name static, that means rest. A body when under rest, it tends to move. The tendency of movement in that condition, the force which applied, this is the definition, the force of friction which comes into play between two bodies when one body actually starts moving the other. In that condition, this force is named as static friction. We will discuss later in details. Now, limiting friction. The static friction, the maximum static frictional force is named as limiting friction. This is a type of static friction, but the maximum value of static friction is gives another name which is named as limiting friction. And there is another part, that is kinetic friction. And kinetic friction means the frictional force which arises when the body is under motion condition. You see the definition. The force of friction which comes into play when a body in a state of steady motion over the surface of another body. So when the body is in relative motion, that is, the body is under motion, in that condition the force which is applied, which is arises, that is named as kinetic frictional force, which is represented by symbol, you see Fk, K for kinetic. And when the body is under rest, there is a tendency of movement. In that condition, the force which arises is known as static frictional force, which is represented by symbol Fs. And the maximum static frictional force, Fs, but the value is maximum, so Fs max is named as limiting friction. Now, in the part of kinetic friction, there are also two types of forces, which is named as ruling friction and sliding friction. What is sliding friction? When a body slides over the surface of another body. When a body slides over the surface of another body, you see, this is the surface and this is the body, and this body it slides. In that condition, the body's movement in the positive x-axis. So here the frictional force which arises is known as the sliding friction, that is directed tangentially in that direction. Now, what is the ruling friction? Ruling friction, that means a body when rolls over the surface of another body. This is the surface and this body is ruling. You see, this body is ruling. So when this body is ruling like this way over the surface of another body, the force of friction which arises in the opposite direction of this motion of that body, that is named as ruling friction. Now, you see the law of kinetic friction. At first we will learn the law of kinetic friction. This is a basic concept, easier than the static friction. Then we will discuss the static friction. Then it will be more clear to all of you. Okay. Law of kinetic friction. So our next point, that is law of kinetic friction. Law of kinetic friction. So kinetic friction arises, our first condition, when there is a relative motion. When there is a relative motion, this is the first condition. Or you can say the body is in the state of motion. Body is in the state of motion condition. Okay. Now second point which arises, this kinetic frictional force is constant. Kinetic frictional force is independent on velocity. That is, a body is moving with how much velocity, 10, 20 or 50, the kinetic frictional force doesn't depend on that. Kinetic frictional force is constant part. So it is independent on velocity. The body is moving faster or the body is moving slower, it doesn't depends. Okay, so second point, the kinetic frictional force gives a constant value, that is independent on velocity of the body is moving. third point is very important. Kinetic frictional force, which is named as Fk, is directly proportional to the normal reaction force. You see, this is the body, this is the surface, body is under motion. So this is the displacement of the body mass m. This is the body mass m, same body in under state of motion condition. Now at a time, suppose here the body weight, that is W, is equal to m into g, is directed vertically downward, and we already learned that in the normal direction, normal to the surface, there is a force which is named as normal reaction force, and the body is moving along that direction. That means an external force is applied along positive x-axis. That's why the body is moving. Now when an external force applied along positive x-axis, there is a frictional force in the opposite direction of this applied force. So there is a frictional force. This is the frictional force, and this frictional force is named here Fk because the body is under motion. That's why it is the friction for kinetic, and this kinetic frictional force is directly depends upon this normal reaction force, and you know this normal reaction force is depends on weight of the body. So this point is very important, students, and with the help of this point we will establish the laws of friction equation. So here Fk, that is equal to mu k into r. When we apply equal, there is a constant here mu k. This constant is named as coefficient of, in general name that is coefficient of friction, but this is mu k, so this is named as coefficient of kinetic friction. So coefficient of kinetic friction. Okay, and you see here this is the direction of r, this is the value of W equal to mg. Here r is equal to mg, equilibrium condition. So you can write this value also, that is Fk equal to mu k into mg. Okay, this is the equation. Now here you see what is the value of mu k. Mu k, that is equal to, from this equation you can write Fk divided by r. So this ratio is gives mu k, that is the ratio of kinetic frictional force to the normal reaction force. This is the ratio of two forces. This one is the kinetic frictional force and this is the normal reaction force, and this ratio is known as the coefficient of kinetic friction. That's why the kinetic friction has no unit and no dimension, because both are this value is the ratio of two forces. So there is no unit of kinetic frictional coefficient of kinetic frictional force and no dimension. Okay, so this is all about kinetic frictional force. Now we will focus on the laws of limiting friction. So before going to that part, at first you observe one important thing. Suppose a body of mass m is placed on a horizontal surface, and I am applying a force, external force F, that is equal to 2 Newton. And I observe that when we apply 2 Newton force, the body is under rest. That means the position of the body is fixed when you apply an external force 2 Newton. So obviously there is a frictional force F, and that value is also 2 Newton. That's why the body is at rest. Now suppose I am applying a force F, I am increasing the external force. I am giving this F, that is 4 Newton. Okay, so initially you are applying a force, external force, that is 2 Newton, and you observe that the body is at rest. So body is at rest, that means there is a frictional force which is named as static. The frictional force which arises at rest condition, and this static frictional force is exactly equal to the external force. That's why the body is at rest condition. Now I am applying an external force of 4 Newton, that is I am increasing an external force, and I also observe that, so when I apply an 4 Newton force, the body is also at rest. So in that condition, the frictional force, that is also equal to 4 Newton. As external force increases, like this way the static frictional force, you must say this is static frictional force, the static frictional force is also increases. So the question is, at rest condition there is frictional force. Yes, at rest condition there is frictional force, which is static frictional force, and this static frictional force is just adjusting its value in accordance with the external force. That's why this static frictional force is another name, is named as self-adjusting force. Is important question. Why static frictional force is called self-adjusting force? And the answer is, this frictional force is adjusted its magnitude value in accordance with an external force. Okay, now for this part, suppose I am increasing this external force 6 Newton. So when I am applying an external force 6 Newton, and I also observe that the body is under rest, so obviously the static frictional force is also increases, and that is also equal to 6 Newton. 6 Newton positive x-axis, 6 Newton negative x-axis, so body is under rest. Now when I apply, suppose this is 7 Newton force, the 7 Newton external force, and I observe that the body is under motion. The body is under motion when I apply 7 Newton external force. That is when the frictional force which arises is known as kinetic. Body, when already body in motion, there is a kinetic frictional force. But you see, external force increases, like this way static frictional force increases. So the static frictional force is not a constant. The static frictional force varies. Its value increases with the increase of which value? External force, linearly, up to a limit, up to a maximum limit. You see, frictional force increases to 4, 6. Suppose this is the maximum frictional force, and when I applying an external force 7 Newton, and the body is going under motion condition. So this is the maximum frictional force. This is the maximum frictional force. Okay, write it, maximum frictional force, and this maximum frictional force is named as limiting frictional force. This is the concept, limiting frictional force. So limiting frictional force is a part of static frictional force. The maximum static frictional force is named as limiting frictional force. Okay, so what is the laws of limiting frictional force? So first point, limiting frictional force depends on nature of the surface of contact, nature of surface of contact, and also the state of the polish of that surface. Second point, limiting frictional force is direction obviously in opposite to the direction of motion applied force, that is the tangential direction, tangential to the surface of contact, tangential to the surface of contact. Third point is very important, that is limiting frictional force Fs max is directly proportional to same normal direction force, like the laws of kinetic friction. So this one Fs max, that is equal to mu s into r. This is a constant part, mu s, and this mu s is known as coefficient of static friction, coefficient of static friction, or you can say this is the coefficient of limiting friction also. Limiting friction is a part of static friction, but this is the not laws of static friction. You know, the static friction value is not constant, that is variable. Static friction value is variable, and a variable value doesn't give a particular law, it has a method. So this is the laws of limiting friction. Okay, now what question is, what is the relation among limiting and the static friction? What is the relation? Which value is higher? You observe this one. This one static friction 2, 4, 6, 6, 6, 6 static friction. But this is the maximum value of static friction. And this maximum value is named as limiting friction. So 6 static friction and 6 also named as limiting friction. So you can say the Fs max is equal to Fs. This is the condition. You see, 6 is a static friction, but if this is the maximum value, that's why this is also limiting friction. And you see, Fs max is greater than Fs. 4 Newton, this is the value of Fs, but Fs max, which is 6 Newton, is more than 4 Newton. Similarly, Fs 2 Newton and Fs max 6 Newton. Here 6 Newton is more than Fs, that is 2 Newton. So you just add these two equations. So you can write Fs max greater or equal to Fs. So this is the relation between static friction and the limiting friction. Okay, and what is the relation among kinetic friction and static friction, or you can say this one is limiting friction? What is the relation? Kinetic friction, when the body is under motion condition, the friction is less than the kinetic friction, less than the limiting friction. Limiting is the maximum. When we apply in 7 Newton force, the body is under motion, and the maximum limiting, that is value is 6 Newton. So the body overcome this frictional force. That's why the body is under motion. So when body is under motion, in that condition, the frictional force is slight decreases, and then remains constant. So here, if K is less than Fs max. So from here you can write, you see, if K, that means you already proved mu K into R, and Fs max, that is mu S into R. Mu S into R. R cancel out, that is mu S greater than mu K. This is also an important part, student. Mu K is mu S is greater than mu K, that is the coefficient of static friction is greater than the coefficient of kinetic friction. And what is the relation of static friction? Static friction, that is equal to Fs max divided by R. So this is the ratio of two similar quantities. So it has also no unit, no dimension. Okay, so this is the laws of limiting friction. Now is most important, if we draw a graph, the applied force versus frictional force, what will be the nature is very important, students. So draw this one. If we apply a graph, x-axis is represent applied force, x-axis is represent applied force, and y-axis is represent, suppose, frictional force. So in general condition, you observe this one, when applied force 2, frictional force is 2, that is frictional force is adjusted according to the applied force. Applied force 2, frictional force 2. So this is the point. Applied force 4, frictional force 4. Applied 4, frictional 4. So this is the point. That means F directly proportional to Fs is directly proportional. So initially the graph will be straight line. Okay, now at a particular point, this applied force, when you apply 7 Newton, the body is under motion. That means it's overcome its inertia. Okay, so this force is increases maximum. This maximum force, you see, this maximum value is the limiting. This maximum value is indicate limiting friction. Limiting friction. Initially, F is directly proportional to small f, then it increases its maximum value, then its slight decreases, and then it remains constant. And this is under motion condition of the body, and this is under motion condition, and up to this portion, under rest condition, and this region, that is just the body just starts moving. So body when just starts moving, in that condition the frictional force is maximum, and this maximum force is frictional force is known as the limiting frictional force. So this is the diagram between F and capital F, and this diagram is very important, students. And there is also, in case of kinetic frictional force, there is sliding friction as well as ruling friction, and the law of ruling friction states that, you see the law of ruling friction. First point, ruling friction, which is represented as Fr, R for ruling, is directly proportional to R, that is the normal reaction force. And the second point, ruling friction is inversely proportional to the radius of the ruling body. If this one is ruling over the surface, this one, so this cylinder has radius, so this radius is inversely proportional to this frictional force. It is experimentally shows that. Okay, so ruling frictional force is inversely proportional to R. R is the radius. So now combining, you can find out the formula of ruling frictional. Combined it, that is Fr is proportional to capital R by small r, that is Fr is equal to mu r capital R by small r. Here mu r is called the coefficient of ruling friction. Okay, but if you calculate mu r, you see mu r, that means this one r Fr divided by capital R. Mu r has unit, mu r has dimension, but mu k and mu s has no unit, no dimension. Why? You see, in case of mu r, there is an additional part small r. This is Fr, there is a type of force. This is R, reaction is also type of force. This unit and this unit cancel out, but there is an additional part which is R, and R is the radius. So mu r has unit which is named as SI system meter, CJ system centimeter, and it has also dimension, that is L, m0, t0, L. Okay, so this is all about laws of friction. So we learned the laws of limiting friction, the laws of static friction, the laws of kinetic friction, and the laws of ruling friction. Now we will discuss some basic concept. This part is very important, students, for beginner. So see the basic concept of basic numericals of frictional force. Suppose, write it, a body of mass 2 kg, a body of mass 2 kg is placed on a horizontal surface, and an external force F, that is 2 Newton, is applied along the positive x-axis. And here mu s is given, suppose 0.2, mu k is given 0.2. Now question is, at first you have to find out the frictional force. So write it, first question, you have to find out frictional force. Now second, you have to find out the acceleration of block, or you can say body. You have to find out acceleration. So for finding acceleration, or for finding frictional force, at first you have to find out the limiting friction. Okay, find it. You see, you know the formula, limiting friction, that is Fx max, that is equal to mu s into r. You see, the body of mass 2 kg, so downward direction 2 into g, that is the weight. Suppose here g value is 10 meter per second square, so this value will be 20 Newton. Now here the normal reaction force is directed normal to the surface, external force F, that is equal to 2 Newton, and frictional force, here this is the direction of frictional force, so Fs max, that is equal to mu s, and what is R? You see, R is equal to 20 Newton, so that is mg, so mu s value 0.4, m that is 2, and g that is 10. Now solve it, 10 cancel out, that is 8 Newton. Now you observe, is important. External force 2 Newton, but frictional force, that is maximum limiting frictional force 8 Newton. That means here the frictional force Fs, that is 8 Newton. Is it possible? Yes or no? Is it possible? The body external force applied is 2 Newton along x-axis, but here frictional force is directed in the opposite direction, which is more than the external force. See, if external force is greater than Fs max, this is the condition, that means the body under motion. But if Fs max is greater than F external, that is body at rest. So here Fs max is greater than F external, so body at rest, and when body at rest, acceleration A is equal to 0. There is no acceleration. This is the concept. Okay. Now question is, what is the value of this frictional force? The answer is 8 Newton or anything else. Answer is not 8 Newton. 8 Newton answer means the when you apply an external force 2 Newton in the positive x-axis direction, the body is moving backward because this force is 8 Newton. Is it possible? No. Frictional force, the static frictional force, is adjusted its value in accordance with the external force. So here the maximum static frictional force, that is the limiting frictional force, will be equal to external force, that is 2 Newton. That's why the body is under rest. You see, the body is under rest, and body is under rest, that means when there is a 2 Newton force along positive x-axis, so obviously the negative x-axis force will be 2 Newton, not 8 Newton. 8 Newton, that means the body is moving backward. That is not possible. So this is the concept. The static frictional forces adjust its value in accordance with the external force. So here your answer will be Fs, that is 2 Newton. Okay. Now take another problem. This problem I am just increasing this external force value. Okay, increase it. Body of mass 2 kg, but here external force F, that is directed along positive x-axis, 10 Newton, and here mu s value is same, that is 0.4, and mu k value is also same, that is 0.2, and condition is also same. You have to find out frictional force, and second you have to find out acceleration. Same problem. I'm just increasing this amount. Now you solve it. Okay, solve it. So at first you solve which one? At first you find out Fs max. Fs max, that is equal to mu s into r, and mu s r, that means mg. You draw FBD for this figure, free body diagram. That is 2 into 10, 20 Newton in the downward direction, that is the weight. Here G is 10, you just consider, and in the upward direction, that is normal reaction force R. Here F, that is 10 Newton, and here there is a frictional force Fs max, or you can say Fx. So Fs max, that means mu s, and R, that is balanced with mg. So just putting this value 0.4, m, that is 2, and g, that is 10. So this is 10 cancel out, that is 4 into 2, that is 8 Newton. Now you see here external force 2 but frictional force 8, so the body is under rest, but here external force 10 and the maximum frictional force 8. So here F external is more than Fs max. So in that condition, body is rest or motion. In that direction, its force is more than the backward direction force. So body must be in motion condition. Clear to all of you? Okay. Now second part, what is the acceleration? So for finding acceleration, at first you have to find out net force. So write it, net force, F net, that is equal to M into A. Now net force, that means positive x-axis 10 Newton, negative x-axis 8 Newton. So net force, that means the higher force minus of lower force. So higher force, that is 10, minus lower amount of force, opposite direction force, that is 8. So that's why minus. Okay, when two forces are along the same direction, net force F1 plus F2. But here two forces are in opposite. So the net force which moves the body forward, that is 10 minus 8. That is equal to here M2 and acceleration. You have to find out this value. So 2, that is equal to 2a. So from here you can say acceleration 2 by 2, that is 1 meter per second square. This is the concept, student. Now question is, what is the answer of Fs, frictional force? You see, this is the not answer. 8 Newton is not the answer. Here mu k given. If mu k given in a numerical, and you know the body is under motion, so when the body is under motion, you must have to find out Fk. So Fk, that is equal to mu k into r. Mu k, that is 0.2, and r, that means the weight, m into g, that is 20. So this value will be 4 Newton. The first question answer will be 4 Newton. But in most of the problem, if mu given, not mu k, not mu s, in that condition we will just use the formula, that is F equal to mu into r, not mu s, not mu k, not to use Fs, not to use Fk. Okay, in most of the problem, suppose the question given mu, and this is the normal condition. Okay, but if the value given separately mu k and mu s, then you must have to find out the value of Fk with the help of mu k, because here the body is under motion. And what is the condition for finding the body motion or rest? You find out the maximum the maximum static friction, that is the limiting friction. See, if the limiting friction is more than the external force, that is the body rest. If external force is more than the limiting friction, the body is motion. Okay, now let's take another example. And this is the basic concept, student, basic numerical. And this type of numerical is very important for the beginner who are learning frictional force new. Okay, now problem 3. Suppose this body of mass 4 kg is placed on a horizontal surface, and a force F, that is equal to 10 Newton, is directed like this way. 10 Newton is directed like this way by making an angle 30 degree with this horizontal direction. Here you have to find out first, that is frictional force, second, that is acceleration. Now what is the process? You see, here force is directed by making an angle, so here force has two components. So you just make FBD 4 kg, so 4 into 10, that is the weight. You consider G is equal to 10 meter per second square for simplicity. So W equal to 4 into 10, that is 40 Newton. Okay, force is directed in that direction. This is the angle 30 degree. So this value is F cos 30. So what is the answer? F, that is 10, and cos 30 value. What is the value of cos 30? That is root 3 by 2. So this value is 5 root 3 Newton. And the vertical direction, this one is F, you know, F sin 30, and F, that is 10, and the sin 30 value, that is half. So this value is 5 Newton. Okay, and also there is normal reaction force, and in the opposite direction of external force, opposite direction of F cos 30, there is frictional force F. Now you observe, when you find out this value, that is Fs max, you know the formula, that is mu s into r. But at first you have to find out r here. here R is not equal to m into g. Here R and F sin 30 is directed vertically upward. So R plus F sin 30, that is equal to the downward direction force, that is mg. So what is R? R equal to mg minus F sin 30. mg, m that is 4 and g 10, so this one is 40, and F sin 30 we already calculated, that is 5. So this answer is 35 Newton. Here R is 35 Newton. So R is not always equal to mg. Okay. So now you just calculate F is max, that is equal to, okay, suppose here question mu s given 0.2. Okay, so this value will be 0.2 into, that is 35. So this one will be 2, this one is 7, 2 to cancel out, so this is 7 Newton. F is max, that is equal to 7 Newton. This is 7 Newton, and the forward direction force, that is 5√3. Okay, now if this value is more than this one, then we can say the body is under what? Motion. You see, forward direction force, that is F cos 30, and F cos 30, that is 5√3. You calculate this value, and you know the value of √3, 1.73 approx. So this one will be more than 8 point something. Okay, you just calculate it. This one will be 8 point something, and this value is backward force, that is 7. So this one is 8 point something and this value is 7. So external force, that is F cos 30, is more than the limiting frictional force. So obviously the body will be under motion condition. Body will be under motion condition. And when the body will be under motion, what will be the acceleration? You calculate F net, that is equal to m into a. F net, that means forward direction force 5√3, backward direction force, that is 7, that is equal to m, that is 4 into a. So acceleration is equal to 5√3 minus of 7 by 4 meter per second square. Okay, so this is the basic problem, basic conceptual problem related to friction. At first you solve these types of problem, go back to your exercise book and solve it. Then after that you solve the higher thinking problem of frictional force. Today I am ending here. I think this video is clear to all of you students. Meet you in next class, and in next class we will derive, we will learn the angle of friction, angle of repose, the relation between them, and we will solve the higher thinking problem. Today I am ending here. Meet you in next class. Bye bye.